So in the last video, we talked about what were variables, constants, and the concept of shadowing. So in this video, we are going to talk about another Rust concept called as ownership. Now, this is one of the concepts that make Rust special because this is a Rust unique concept. And once you understand ownership, you will understand many different concepts as to why they are so in Rust. So let's get into it. So in the previous video also I discussed the rules of ownership. Namely, each value in Rust has an owner. There can be only one owner at a time, and when the owner goes out of scope, the value will be dropped and you will no longer be able to access it. So let's try to understand these three rules by examples. So in the first example, we are declaring a value s, declaring a variable s, and binding it to the string literal hello world. So the s is the owner of the string literal hello world over here, and as long as s is inside scope, you will be able to access it and do stuff with it. So same is explained in the next code snippet that this is a scope defined by the curly braces. Inside it, we are declaring the string literal s, which is equal to hello. Now, before we declare it, we won't be able to access it because obviously it is not yet declared. Now, the point on from which it is declared, we will be able to use it and do stuff with s. And once we encounter the closing curly brace, the scope will be over, and then s will be no longer be valid. It will be dropped. So yeah, let's try to code this example and see in VS Code on the right side. So I'm declaring s, which is equal to the literal hello, and let's put this inside a code block, something like this. And then let's try to access s outside this code block, outside the code block mentioned by the pink curly braces. So I'll try to print the value of s outside the code block. And let's save the code. As you can see, the moment I save the code, I get an error, a red squiggly line and res. And let's try to read through the error. For that, let's check our code by the cargo check command. Yeah, as you can see, we get an error saying the binding s is available in a different scope in the same function. So yeah, it is basically saying that the scope is not same, so you cannot access s over here because as soon as we encounter this closing curly brace, the value of s will be dropped. It will no longer be valid. You won't be able to access it. So this is basically what is mentioned over here. And yeah, so we need to take care of the scope and see which values are valid from where to where. So yeah, to properly understand the rules of ownership, let's take a more complex data type. So in Rust, there are two string data types. One is the string, and then other is the at string, which is known as the string slice type. Uh, so same rule applies to the string type. The value will be valid from the point on it's declared, and it will stay valid within the same scope. And the once the scope gets over, the value will be dropped. So let's understand this example first. We are declaring a mutable variable s, which is equal to the string literal hello. We are forming a string type from the literal hello. So the type of s will be a string, not string literal. Then we are pushing a string literal to s, appending a string literal at the end of s using the s dot push str function, and then we are just printing the value of s. So I hope you will be able to guess what the value of s will be here. It will be just hello world. uh, in the next code snippet, we are just trying to show that the same rules apply to a string type as we saw in VS Code with the string literal type. We won't be able to access the value of s outside the scope. We can do whatever we want to do with it inside the same scope. Okay. Now let's take a simpler data type like integer. We are declaring an integer x which is equal to 5. Then we're declaring another integer y which is equal to x. So as you guess, the value of y will also be 5 over here. Now we are going to understand a very important concept of moving data. So for that, let's see this code snippet over here. So we are declaring s1, which is of a string type and contains the literal hello. And then we are declaring s2, which is equal to s1. And then we are trying to access s1, trying to print s1. So let's try to code this in VS Code and see what the error is, because obviously this code won't compile, and let's try to understand why that is so. So I commented the previous code. Let's write this code. Let s1 equals to string colon colon from literal hello. On the next line, I declare s2. Let s2 equal s1, and then I try to print the value of s1. Let's save this code. As you see, I get a red squiggly line under s1. Let's check this code using cargo check and read through the error. So I'll just clear the terminal and cargo check. So as you see, I get an error. Now the reason for this error is that we are trying to print a value that was moved from its initial location to a new location. Now let's understand this, why this is happening. So when initially I declared s1, it contained the string made from the literal hello. Then when I do let s2 equals to s1, no matter the value of s2 will be same as s1, but the s1 variable will be moved and then put into s2. So s1 will no longer be valid, as it has been moved from its initial location and put into s2. So we can access s2 from here onwards, but not s1. So I hope you understood that. So we'll understand this in more detail, but this is not the same thing that happens with integers. Even if you move the value of an integer, it will still be accessible. Let's say in this example, let x equals to 5 and let y equals to x. So you might think that over here too the value of x will be moved into y, and we would no longer be able to access x, but that is not the case. Even after these operations, we are still able to access the value of x. Let's try to code that and see. So I just declare x, let x equals 5. Then I declare y, let y equals x. And then I trying to print the value of x. Let's save this code. As you can see, I get no error whatsoever. Now let's try to actually run this code, verify it for ourselves that this is actually a valid operation. Now let's check it first with cargo check command. As you can see, we get a warning but no errors. Now let's try to run it. Yeah, so it printed the value 5. So this is a valid function. Now why is this happening? In case of integers, we are able to access that value after it has been moved, and in case of a more complex data type like string, we aren't able to access that because it has been moved from its initial position to later position. We'll see that in detail. Let's understand this over here. So a string type like s1 is stored somewhat like this in our memory. Its pointer, length and capacity is stored on the stack, and then it is pointing to a value on the heap. So the value will be stored as a characters h, e, l, l and o, and the pointer will be pointing to the index 0, which is the first character, which is h. So the left portion will be stored on the stack, and the right one, which is the value, that will be stored on the heap. I'm sure you know the reason of it now if you have watched the first video. And when actually we make the second variable, let s2 and make it equal to s1, so only the stack content is copied, but the heap content remains the same. So we'll make another s2, which will also contain a pointer field, a length field and a capacity field, and its pointer will also be pointing to the same hello stored on the heap. And after this, the first copy on stack will get invalidated. So we first had s1 on stack pointing to the value hello on heap. Then we made s2, which is similar to s1 on stack, and then pointed it to the same value on heap, which is hello. And after that, we invalidated the first copy on stack, which is the s1. So now the value hello on heap will only be accessible through s2. So this is what actually happens. If you are from any other language background, I hope you know the concept of deep copying and shallow copying. So basically, what shallow copying is, we only copy the contents of stack, not the heap. And what deep copy means, we also copy the contents of heap. So what is happening over here is a shallow copy, not a deep copy. So we are copying the contents of the stack and making it point to the same object on the heap. And while doing so, we are just invalidating the first copy on stack which pointed to that data on heap. So that is the reason we would no longer be able to access S1 after this operation, and only S2 will be accessible, but it will contain the same value, which is the string from the string literal hello. So yeah, now let us consider this example over here. We are declaring a mutable variable s which contains the string from the literal hello. Then we are changing the value of s. As it is mutable, we are able to do so. So now we are making s equal to the string from the literal ahoy. So what is happening here is a deep copy. Now let's understand this. First, we had a stack copy with a pointer length and capacity field. The pointer was pointing to a value on heap which contained hello, hello. Then after we write the second code, s equals to string from ahoy. Then another value will be made on the heap, which will contain the value ahoy. And then our value on stack will point to the newly created object in the heap, and the previous initial object or initial value on the stack will get invalidated. So here we are copying the contents of the heap. uh, Instead of copying, I must have said here we are creating a new object on the heap. Not we are not copying the contents of stack and making the initial contents of stack point to the new object on the heap. So this is the concept of deep copying, where we copy, or I must say, you know, make another object on the heap and not just copy the contents of stack. And shallow copying, we were just copying the contents of the stack, not the heap. So yeah, this is another example illustrating the same thing. We have a s1 which is a string. Then we are declaring a variable s2 which is nothing but s1 dot clone. Now what the dot clone function does is that it makes a deep copy. The object on the heap will be cloned and s2 will be containing that object. But because we are cloning the object, the initial copy won't be invalidated, and so s1 will also be valid after this operation. Now, over here, we were not cloning anything. So the value of S1 was moved into S2. But as in this example, we are actually cloning it. Then, this example, we are actually cloning the value of S1. So there will be two objects on heap now. And yeah, both S1 and S2 will be valid. So why is that so that more complex data types like strings behave in this manner, but integers not, like the basic data types do not? So this is because of the copy trait. Now we'll look into traits in much detail in further videos. But for now, we must understand that all the basic data types like integers, boolean types, floating point values, characters, and also tuples, all these implement the copy trait. So if you perform any operation like this, declare one variable, then make some other variable equal to that variable with any of these data types which I mentioned over here, then the previous variable won't be invalidated. Because these variables implement the copy trait. Means they implement shallow copying. The stack contents will be copied, and everything apart from these implement the drop trait. So we'll talk about traits later. So yeah, they implement the deep copying concept. So that is why the value of the first variable won't be valid after you have moved its value into some another variable. Now let's consider this example. Let's try to understand it. In the main function, we are declaring a string variable s and making it equal to the string from the literal hello. So with this line, s comes into scope. Now we have declared a function take ownership, which in which we are giving the argument s. So the concept of ownership works like, even if you pass some value inside the parameters of a function, the value will be moved. So s was the owner of the string hello. Then we gave this s as an argument to the take ownership function. So s was moved inside this function. Now after this line take ownership with s, we won't be able to access s anymore after this take ownership call, because the value of s is moved inside the function. And now the function, now this function is the owner of the owner of the value hello, and s won't be accessible after the call to this function. But if we take a simpler data type, like let x equals to 5, which is a i32 integer data type, and then pass it to a function makes copy. So now, even if we are giving x as an argument to this function, we will be able to access it after the function call, since integers implement the copy trait. We'll discuss more about copy traits later. For now, just keep this in mind. And when the main functions end, when the main function will end with this closing curly brace, both x and x will go out of scope, and s, the value of s was already moved into the function, so it will just be dropped. I mean, nothing will happen to s as such, because its ownership is lies with the function take ownership. So yeah, s is not present in the main function anymore, so only x goes out of scope and it will be dropped. Nothing will happen to s. And the take ownership function takes a string as an argument, so a string will come into scope, then it prints the string. And as the take ownership function ends, the string which had given to it, moved into it through the arguments, now goes out of scope, and the drop function will be called on it, and its memory will be freed, and now you can no longer access that string as well. And the make copy function takes an integer, so the integer comes into scope, which we passed over here. We passed x into the makes copy function. But yeah, as integers implement the copy trait, the value of x will be accessible after the makes copy function call in the main function as well. And over here also, in the function body, the value of x will be accessible. We can print that integer, and here x goes out of scope, but nothing special happens, because we didn't actually have the ownership of x, so we cannot drop it. The ownership of x still lies with the main function. In this next example, we have declared a string s1 in the main function, which is equal to the string from the literal hello. Then we are declaring a tuple having an s2 and a length, and making it equal to the return of the calculate length function, in which we are giving s1 as an argument. Now let's see what the calculate length function does. Now it is a function that accepts a parameter s, which is a string, and then returns a string and a u size, which is a data type, integer data type. You can basically understand it like that for now. We'll get into data types later. Then we are declaring length, which is equal to the return of s dot length. Now dot length function just returns the length of a string, and then just we are returning s and length, which is a tuple, which will be stored in this s2 and length function. And then we are trying to print the length of s2. Now over here, we are declaring a string s1, then passing it on to the calculate length function. So s1 is moved inside the function. You might think it will no longer be valid over here, but that is not the case, because the calculate length function is taking a string, but it is also returning the same string. So the calculate length function will return the string it initially had gotten from s1, and place it into s2. So now s1 is no longer valid, but the same valid is accessible through s2. So I hope you understand this function. Now I'll explain it once again. First we declare s1, which is equal to the string from the literal hello. Then we declare a tuple s2 and length, which is equal to the return of the calculate length function, and inside the calculate length function we are passing the argument s1. So s1 is no longer valid because it is moved into s1, but the calculate length function is taking a string, and it is returning the string as well its length. So now calculate length function will return the value of s1 into s2 as well as the length of it. So s1 is no longer valid, but what was inside s1 is still accessible through s2. So I hope you understand this function as well. And let's take a look at the last example of the day. I hope you understand everything till now, and once you understand this example, you will understand everything related to ownership. So in the main function, we are declaring a string s1, which is equal to the return of the give ownership function. Now, what the give ownership function is doing, it is returning a string. It is taking nothing but just returning a string, which is some string which is declared inside the function body, which is equal to the string from the literal hello. So some string will be equal to the literal yours, and it will be returned via this function. So give ownership is returning the literal yours of string type, obviously, and placing it into s1. So the function give ownership, or rather the variable some string, was the owner of yours over here. But with the return of some string, the ownership of the literal yours was moved into s1, because s1 is equal to the return of the give ownership function. Then next, inside the main function, we are declaring a variable s2, which is equal to the string from the literal hello, and then s3 equals to the return of the takes and gives back function with the argument s2. So s2 contained hello, we moved s2 inside s3, and now s2 will no longer be valid after after this operation. And s3 is nothing but the return of the takes and gives back function. What that does is takes a string and returns the same string. So s3 will be equal to what the value of s2 was, basically. So s3 will be equal to hello, and s2 will no longer be accessible because it was moved inside this function call. So the same is written in concept in comments over here. The gives ownership moves its return value into s1. Then after that, s2 comes into scope. S2 is moved into the takes and gives back function call. Then S3 goes out of scope, and with the end of the main function, S3 will go out of scope, so it will be dropped. S2 was moved into S3, so there is nothing as such to drop over here, because we moved the value of S2 into S3. So S3 was nothing but S2, and we dropped S3 already, so we cannot free the same memory again. You might knowing that concept if you have seen the last video. So yeah, so s2 is no longer accessible, so nothing as such, the drop function will be called on s2. And yeah, there was a value in s1, so yeah, that will go out of scope with the end of main function, and it will be dropped. So that is basically this code. I hope you understood the concept of ownership, how there can only be one owner at a time, and every value has an owner, and when that owner goes out of scope, the value will be dropped. I hope you understand how we can move the ownership of some value and give it inside a function as an argument, and that value will no longer be accessible after that function call, but can be accessible if that function call is again returning that same value through some another variable. So yeah, that was all about it. I hope you understood the concept of stack only copy, which is also known as shallow copying, and deep copying, in which we actually copy the contents of the heap or make another object on the heap, and how the integers implement the copy trait, so their value will be accessible even after we move it into another variable, and how we won't be able to do the same thing with some complex data type like string, which is stored on the heap and not on the stack. Then yeah, these are the basic concepts of ownership. I hope you understand. We'll encounter these concepts as and we move on through the playlist, because ownership is a very important concept in Rust, and we'll encounter it in almost everything that we do in Rust. We'll have to take care of these rules so that we don't get a compile time error, or we won't be able to get a runtime error, because Rust enforces these concepts at compile time itself. So if you have not followed these rules, if you have made any mistake, your code won't get compiled in the first place. And yeah, that is basically it about ownership. I hope you understood. If you have not understood, go through the video once again, because this is a pretty much advanced concepts, and beginners won't understand it in the first go. And if you haven't watched our previous videos, I highly recommend to watch them. And yeah, I hope you like the video and subscribe. Thank you.